So I went and just before class, I did 3 recordings. And just so you can see the recordings, I did 3 recordings. And if you look at them, mine came out in that high density video. So I had to go out and do a conversion. And just to remind folks, you can just go to a site to do a conversion. So if I go over here and I want to do a conversion, I gave you guys a resource to do those conversions for those for videos. Now everything's going slow. There we go. And so there's the site sources, but I think in here I've gotten how to convert videos in here as well. But there's a bunch of them that are there. But I'm going to open up my video analysis tool. And I've done 3 different ones. I've done 2 at regular speed, and I've done 1 in slow motion. But when you did this lab, hopefully you went in and you imported your video because you had it for your drops. And I converted my files from the MP4s to the MOV files. So we're going to use this one right here. So it's going to import the data. I set up my video so that I had something that I could use as a measurement device, which I did. This case, it happened to be a yardstick, not a meter stick. But if I do 36 inches times 2.54 centimeters per inch, divide by 100, and a yardstick is exactly 0.9144 meters. So we've got that in there. And since it came in and imported with the data, that's great. I'm going to go ahead and put myself an origin here. I'm looking at, we're dropping a dog toy in this particular video. I'm coming down here and I don't want to go 1 frame per second. I want to go 5 frames per second because that's going to, or 5 frames. It's as far as it's going to advance. So I'm going to be totally fine there. And now I'm going to collect my data. So I'm going to use the center of mass, just like we talked about last week. And now it will automatically move 5 frames forward. And I'm going to collect my data. And I'm trying to do the center of mass. And you can see that the shape's kind of distorted. So, you're still trying to do the center of mass. So there's one right there. And right there. And that's just before it hits the end of the table. But the other thing I wanted to show here is that it showed that time of fall to be 0.417 seconds. And based on what we calculated last week, that's in the ballpark. If I were off in my frames per second for my video, my value for my time was going to be off. And that's probably where some of you were worried about that you were off. So that's one of the places that you could be there. Now I'm going to go over to my graph options and I'm going to do a curve fit. I'm going to apply our quadratic curve fit. And you can see that, yep, I've got some experimental problems here because my dots aren't exactly on the line. Well, I'm taking real data. My dots aren't exactly on the line. And so that's where some of my experimental error is going to be. And I'm going to hit apply. Now, what you're going to see here is this red line. If I'm looking at the red, that's associated with the data that's in the X direction. If I'm looking at my blue line, this is the data that's associated with the curve fit in my blue line. And yeah, I was sloppy. I didn't do very well. And I can tell you I didn't do very well because this A, that A right there is 1/2 of gravity based on our equations that we've been doing. It's 1/2 of gravity. So mine was going to have to multiply by my 3.8 times 2. And if I multiply 3.8 times 2, I'm going to get 7.6, which isn't the best for gravity. So there's places that I probably had error. My error is most likely associated with this right here. I didn't pick my points very well. I was a little sloppy on my points, and so yep, it's sure enough didn't give me very good data. So that's where you were off. But if that's what you got, that's what you got, and that's what you're going to compare your acceleration due to gravity with. So we could go back and we could clean that up. We could redo it, say, okay, I was really ooky. I didn't really want to do that. I'm going to come back in, make sure that I've cleared out all of my data. I'm going to import my file. I'm going to do the same one. I'm going to go ahead and start it off again. So I'm going to get my values here. I'm going to get my, this is another place where you may have an error. Okay. I may not pick my measuring device just correctly. I've put in those. I'm going to give myself my origin. All right, I'm going to start there. And now I'm going to add my data, and I'm going to go in and I'm going to pick my points. This one's now going to move one frame at a time. Well, I'm not going to do that. I'm going to do a few more down here. Move it in. There we go. So I've got some better data, maybe not. I'm going to apply my curve fit. I'm going to do my quadratic, and I'm going to apply. And that one didn't turn out any better. So for those of you that are worried about, Mother Nature isn't fair sometimes, earlier today, right before class, I got 9.78. So you do get some distortion there, and you can play with it. And it could be your frames per second for your recording. So I'm going to do one that was a slow motion. So we're going to come back and do the slow motion one. But here's the trick on your slow motion is that you've got to make sure that your frames per second is set up correctly. So this one I did in slow motion. All right. And the first thing it tells you is something's not right, because this particular video says it's going to be 13.25 seconds. That's not right. Well, I happen to know that my phone actually records at 360 frames per second in slow motion. So I'm going to use my 360. I'm going to do advancing 2 frames. So I have that set up correctly. I'm going to do my system again. There's my system. Do my 0.9144. I'm going to get my origin in here. All right, now I'm going to add my data points. And because I'm not getting near as smeared out, it looks like my data is coming out a little better. Now I'm going to go ahead and do my quadratic curve fit. I'm going to apply. And now I've got something that looks like a -7. Well, that's still not the greatest. That says gravity is 14. So obviously I still have some experimental error. So you don't get counted off for experimental error. That's not what we're doing in the lab, but that's what will help you get this to play with the gravity and playing with your video. But you can actually see that, hey, you can really do physics at home, and we can do a variety of different things. So that's one piece there. I'm going to stop my sharing. I'm still going to record because I'm going to share my other screen, because I had one other question. Was they were concerned about how we were sharing, or what you needed to do with your Firefox. So I'm going to get my cell phone out here. So here's my cell phone with Firefox. I open up my Firefox. I open up my acceleration with gravity. I go to my absolute. I run it and I stop. And I read my acceleration due to gravity right off of my Firefox application. And that was just another way to measure gravity using the sensors that we have at our disposal. So that's all there was to doing that part. So we're about to do it again. So I'm going to stop recording here.